Deep in the heart of Siberia stands a concrete wall 800 feet high. Behind it, 31 cubic kilometers of water press against the steel. This is the Sayano-Shushenskaya Dam. It was the pride of Soviet engineering until the very machines designed to harness its power turned against it. Beneath the surface sits Turbine 2, a 920-ton steel monster. For nearly 3 decades, it was the heartbeat of the region. But this machine had a secret. It wasn't just spinning, it was shivering. And in the world of high-pressure hydraulics, a shiver is a death sentence. Since its installation in 1979, Turbine 2 was the problem child. Records show it suffered from chronic vibration and seal leaks for 29 years and 10 months. Engineers repaired the cracks, but they never fixed the cause. The system was running in a state of permanent, degraded failure. At 8:13 a.m., the physics of fatigue met the pressure of the mountain. The last of the 80 bolts snapped simultaneously. The turbine cover didn't just leak, it exploded. A 900-ton steel mass was shot 40 feet into the air by a geyser of water under 200 feet of head pressure. This wasn't just a mechanical failure, it was a hydraulic piston effect. With the cover gone, the entire Siberian River was being pumped directly into the turbine hull at 30,000 cubic feet per second. The force of the water alone was enough to move 50-ton concrete blocks like they were toys. As the water surged, it hit the electrical systems. High-voltage transformers began to short-circuit, sending massive blue arcs through the dark, rising flood. The plant's heartbeat stopped as the grid felt the shock of a 6,400-megawatt void. The power went out, and with it, the automated safety systems. The turbine hull was now attuned. 75 workers were trapped in the lower levels as the water rose to the ceiling in less than 3 minutes. The only light came from the blue sparks reflecting off the churning surface. The roof began to fail under the pressure. The structural beams, never designed for an internal surge of this magnitude, buckled and snapped. The pride of the Soviet energy sector was now a pile of mangled steel and flooded concrete. When the water was finally pumped out, the investigators found a scene from a nightmare. 900-ton machines had been tossed like pebbles, but among the wreckage, they found a smoking gun. 80 missing bolts, or rather, what was left of them. Some were snapped, others were completely gone, rusted through years before the disaster. Under the microscope, the truth was even darker. The bolts showed beach marks, concentric rings in the steel that proved the metal had been slowly tearing for 3 decades. The system didn't fail on August 17th. It had been failing since the day it was installed in 1979. The digital reconstruction was undeniable. If even 10% of the bolts had been replaced, the cover would have held. But the system prioritized uptime over maintenance. To replace the bolts, they would have had to shut down the turbine for weeks, losing millions in energy revenue. The paper trail was a hall of mirrors. Maintenance reports from the 90s clearly flagged critical vibration on Turbine 2. Those reports were stamped approved and filed away. The engineers were shouting into a void of corporate indifference. Greed had deafened the system. By the time the investigation concluded, Turbine 2 was a rusted monument to a failed philosophy. You cannot negotiate with the laws of physics. If you ignore the vibration long enough, the machine will eventually find its own way out. This was system failure. The shockwaves of the Sayano-Shushenskaya failure didn't stay in Siberia. Hydro engineers globally were forced to look at their own aging giants. They realized that vibration, the very thing they had lived with for decades, wasn't just background noise. It was the sound of metal fatigue at a planetary scale. New safety protocols were drafted in blood. Every hydro turbine in the Western world was re-evaluated for cavitation and resonance. The system learned that a 900-ton machine doesn't just break. It becomes a kinetic weapon if the mounting bolts are ignored for even a single season. The trial in 2014 was a hollow victory for the families of the 75 lost. Former directors were sentenced to 6 years in prison, less than a month for every life taken. It was the same story as Sampung. The individuals who prioritized the uptime numbers over human lives rarely paid the full price. The dam itself survived, but its soul was gone. It took 5 years and billions of dollars to rebuild the hull. Today, the new turbines are fitted with thousands of sensors that report vibration in real time to a global monitoring net. The era of guessing if a machine is safe is over. But sensors are only as good as the people reading them. The ultimate lesson of the Siberian ejection is that technical data is useless if the corporate culture is designed to ignore it. A system can have every alarm in the world, but if greed is the navigator, it will still find the rocks. The Sayano-Shushenskaya disaster wasn't just a failure of a turbine. It was a failure of the entire system that designed, built, and maintained it. It proved that even the most massive structures are fragile when the people who run them prioritize profit over safety. Nature is patient. It will find the smallest crack, the tiniest weakness, and it will exploit it until the system crumbles. The laws of physics are the ultimate judge, and they don't care about corporate profits or government mandates. The 75 people who died in the Siberian turbine hall are not just statistics. They are reminders of the human cost of systemic failure. Their lives were traded for a few extra years of uptime, a few more megawatts of power. Their memory is a monument to the price of greed. As we move into a world of even more complex systems, the lessons of Sayano-Shushenskaya are more relevant than ever. From power grids to software networks, the system is only as strong as its weakest connection. If we don't learn from these failures, we are doomed to repeat them. In the end, every system is run by people. The ultimate safety net isn't a sensor or a protocol. It's the person who is willing to say no when the pressure to keep the machine spinning becomes too great. Because in the world of system fail, the most dangerous part of the machine is the person who refuses to see it breaking. The failure of Turbine 2 didn't just break a machine, it broke an ecosystem. When the oil from the turbine bearings mixed with the millions of gallons of river water, it created a toxic plume that traveled hundreds of miles downstream. The system meant to provide life-giving power was now poisoning the very land it served. In the months following, the Sayano-Shushenskaya effect became a new term in global engineering. It forced a total rewrite of the ISO safety standards for high-pressure hydraulics. Every nation with a Soviet-era dam was forced to ground their grids and inspect their bolts, fearing a silent killer was vibrating in their own basements. Experts now look back at the 2009 ejection as the Chernobyl of hydropower. It wasn't just a breakdown of metal. It was a breakdown of the culture of normalized deviance, where seeing a machine shake for 30 years becomes so normal that no one remembers it's a warning sign. Today, the Yenisei River flows through the new turbines with a different kind of oversight. Artificial intelligence now monitors the frequency of every bolt, looking for the digital fingerprint of fatigue before a human eye can ever see it. We have traded human intuition for algorithmic certainty. But as we build larger, faster, and more complex systems, we must ask, are we safer, or are we just building bigger systems to fail by cutting the same corners? The machine is only as honest as the data we allow it to see. If the system is programmed to ignore the faults for the sake of productivity, the red catastrophes will eventually become the only thing we ever see. Thanks for watching System Fail. We hope you enjoyed the breakdown of another catastrophic system failure. Please like and subscribe, or head on over to the channel for more crazy system failures. If you are still here, you are the chosen one. What system